Hello everyone, hope you all are in a good health. Today we will be explaining lesson 4.4 proving triangles congruent using the ASA postulate and the AAS postulate. So we're still gonna prove that two triangles are congruent, but now we will be using two new postulates, the ASA and the AAS postulate. So let's first identify the objectives of this lesson. By the end of this lesson, you will be able to Number 1, use the ASA congruence criterion to prove triangles congruent. Number 2, you will be able to use the AAS congruence criterion to prove triangles congruent. But before we start explaining our lesson, let's recall and remember some of the important concepts and ideas that we previously explained in lesson 4.2 and 4.3. So here we go. When two triangles are congruent. When two triangles are considered congruent, two triangles are congruent if they both have exactly the same size and shape. Not only that, two triangles are congruent if and only if, as we see marked here, these two triangles are congruent because their corresponding sides and angles are congruent. In this case, triangle ABC is congruent to triangle MNO. So when referring to corresponding parts of triangle, it's called corresponding parts of congruent triangles are congruent, which is referred as CPCTC, which means that the three sides of the first triangle ABC are congruent to the three sides of the second triangle MNO, and the three angles of the first triangle ABC are congruent to the three angles of the triangle MNO. And please remember the ordering in which we list these vertices is important. So whenever we prove two triangles are congruent, it means that the three angles of one triangle are congruent to the three angles of the second triangle, and the three sides of one triangle are congruent to the three sides of the second triangle. And this is something we covered in lesson 4.2. So is this the only way to prove triangles congruent using the sixth element of each triangle, the three angles and the three sides? Not really. We were introduced to new ways to prove triangles congruent, and let us move and see how. We were introduced to the postulates. We were introduced to the side postulate and the side angle side postulate, and those postulates are used to prove two triangles congruent, and this is something we discussed in lesson 4.3. So in the side postulate, if three sides of one triangle are congruent to the three sides of another triangle, it means those two triangles are congruent. So triangle ABC is congruent to the triangle DAF using the side postulate, since the three sides of the triangle ABC are congruent to the three sides of the triangle DEF. Side angle side postulate, if two sides and the included angle, the angle in between those two sides of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Also here, triangle ABC is congruent to triangle DEF using the SAS postulate, since I have two sides in the first triangle that are congruent to two sides in the second triangle, and the included angle C, as you can see over here, is congruent to the included angle F in the second triangle. So those are congruent using the SAS postulate. So are those, and the question now, are those the only postulates that we can use to prove two triangles congruent? Not really. And in this lesson, we will be introduced to those two new postulates. So let's move to the second slide. So in this lesson, we have two new postulates to learn about. Let's check the first postulate, angle side angle, or the ASA postulate. Let's first look at those two triangles we have and try to figure out what this postulate stands for. So it's angle side angle postulate. So we have two angles in the first triangle that are congruent to the two angles in the second triangle. Not only that, we have the side that is between the two angles in the first triangle is congruent to the side that is between the two angles in the second triangle. So we have angle, a side, angle. So in order, angle, side, angle. While in the second postulate, which is the angle, side, so we have angles, the two angles first, then the side. So let's first look at the two triangles we have. So we have angle, side. So we have two triangles in the first triangle that are congruent to their corresponding angles in the second triangle. But what about the side? We have side S is congruent to side S, but this side is not between the two angles yet, it comes after them. So we have angle, then a side. So it's called angle, side postulate. Let's learn more about each postulate and let's move. Let's first be introduced to what do we mean by the included side. So an included side is the side that is located between two consecutive angles of each polygon. So in case of those two triangles, let's first look at the triangle ABC. So the two consecutive angles are the angles that come after each other, like angle C and angle B. So angle C and B are two consecutive angles. So what is the included side between them? It's a side CB. So for example, if I took the two angles A and B are two consecutive angles, isn't it? They come after each other. What is the included side between angle A and angle B? It's side AB. Let's move to the second triangle. Let's look at angle X and angle Z. Angle X and angle Z are two consecutive angles in this triangle, and the included side within those two angles, angle X and angle Z, is the included side XZ. So let's move and learn more about the included side. Examples of included sides. So let's look at this. This is the same triangle. If you notice, it's a triangle GIH. So the GIH is drawn 3 times. So I have GIH. So first I took the pair of consecutive angles, angle G and angle I. So angle G and angle I are two consecutive angles, while the included side between angle G and angle I, as you see referred here, it's the side GI. Now let's move to the second drawing, IH. So I have angle H and angle I. So I have angle H and angle I are two consecutive angles in this triangle, and the included side within the two angles, angle H and angle I, is the side HI. Now let's look at angle G and angle H in the last drawing. Angle G and angle H are consecutive angles. They come after each other, and the included side, the side that stands between the two angles, is side GH. So no matter which pair of consecutive angles we pick, we can easily determine the included side between the two consecutive angles we have. It's the side that stands between the two consecutive angles. So let's refer to the triangle YES. For this triangle, let's try to figure out the included side for each pair of consecutive angles we have. Angle Y and angle E are two consecutive angles. What's the included side between those two angles? It's side YE. So YE is the side included within the two consecutive angles, angle Y and angle E. While for angle E and angle S, the included side within angle E and angle S is the side ES. While for the two consecutive angles, angle S and angle Y, the included side is SY. So the included side within the two consecutive angles, angle S and angle Y, is the side SY. So let's move and be introduced to the first postulate in this lesson, which is angle, side, angle postulate. So from the naming of this postulate, we can see that the side is in between the two angles. So let's see when we can use this postulate. First, this postulate is used to prove that two triangles are congruent. So if two angles and the included side, so the two angles and the side between them. So if two angles and the included side of one triangle are congruent to two angles and also the included side of another triangle, so we have two angles and an included side, and we have also two angles and the included side in another triangle, then the triangles are congruent. Let's see what we have in this example. We have angle A congruent to angle D. Also angle B is congruent to angle E. So we have two angles in the first triangle that are congruent to the two angles in the second triangle. Is this enough to use the angle side angle postulate? No, it's not enough. We need the included side. As given here, side AB is congruent to side DE. And notice that side AB is the side included within angle A and angle B that's congruent to side DE, which is the side included within angle D and angle E. So we have angle, side, angle postulate to use to prove that the triangle ABC is congruent to triangle DEF. So let's move and have this example about the two triangle ABC and triangle DF. Let's try to prove that those two triangles are congruent using the angle side angle postulate. So technically we need two angles in the first triangle that are congruent to the corresponding angles in the second triangle. Not only that, we need the included side within those two angles in the first triangle congruent to the included side within the two angles in the second triangle. So let's see, angle A is congruent to angle D and angle B is congruent to angle E. So we have two angles in the first triangle that are congruent to their corresponding angles in the second triangle. This is not enough. We need to search for the included side and check whether the included side within the angle A and angle B is congruent to the included side within angle D and angle E. So AB is congruent to DE as you see in the figure. So we have two angles and the included side of one triangle, which triangle ABC. They are congruent to two angles and the included side in the triangle DEF. So we can use the angle side angle postulate to prove that triangle ABC is congruent to triangle DEF. And let us move to the next slide. Name the triangles that are congruent by ASA postulate. So we have to specify which of those triangles are considered congruent if we are using the ASA postulate to prove triangles congruent. Let's check the first example. Let's consider triangle SRQ as the first triangle, triangle VTU as the second triangle, and triangle ZYX as the third triangle. Let's specify and check the angles first. We have angle R congruent to angle T, congruent to angle Y. Also, angle Q is congruent to angle U, congruent to angle X. So we have two consecutive angles in the first triangle that are congruent to two consecutive angles in the second triangle, also congruent to two consecutive angles in the third triangle. But side RQ, which is the side included within angle R and angle Q, is congruent to side TU, which is the side also included within angle T and angle U. So side RQ is congruent to side TU, but they're also congruent to side ZX. But is the side ZX the side included within angle Y and angle X? No, since the side included within angle Y and angle X is the side YX. So we can use the angle side angle postulate to prove that triangle SRQ is congruent to triangle VTU, and this postulate cannot be used with the third triangle. It can be used with those two triangles since we have two angles and an included side on the first triangle, which is SRQ, that are congruent to two angles and the included side in the second triangle, which is triangle VTU. Let's move to the second example. Let's take the triangle ABC as the first triangle. Let's consider JKL as the second triangle, and let's consider EFD as the third. Let's first check the angles. We have angle A congruent to angle J, congruent to angle E. Also angle C congruent to angle L, congruent to angle D. So we have two angles in the first triangle congruent to two angles in the second triangle, that they are also congruent to two consecutive angles in the third triangle. So let's specify or check the sides now. So we have side AC, which is the side included within the two consecutive angles, angle A and angle C. The side AC is congruent to side JL, where JL is the included side within the two consecutive angle JL. AC is ABC is congruent to JL, and it's also congruent to FD. But is FD the side included within angle D and angle E? No, the side included within angle D and angle E is the side DE. So in this case, we can use the angle side angle postulate to prove that the triangle ABC is congruent to triangle JKL, since we have two angles and the included side, as you can see, congruent to two consecutive angles, as you can see, and the included side, which is JL in the second triangle. Let's move to the third example. We have triangle HIJ, we have triangle QRO, and triangle NPM. So let's start first with the angles. We have angle H congruent to angle M congruent to angle N. Also angle G congruent to angle O congruent to angle M. So we have two consecutive angles in the first triangle that are congruent to two consecutive angles in the second triangle that they are also congruent to two consecutive angles in the third triangle. Now let's check the sides, because we need two angles and an included side to use the angle side angle postulate. So we have HG. HG is the side included within angle A and angle G. HG is congruent to QO, and QO is the side included within angle Q and angle O. HG is congruent to QO, and it's also congruent to NM, and also NM is the side included within angle N and angle M. So here we can use the angle side angle postulate to prove that triangle HIJ is congruent to the triangle QRO, also congruent to the triangle NPM. So those three triangles are congruent using the angle side angle postulate, because we have two angles and an included side in the first triangle that are congruent to two angles and an included side in the second triangle that are congruent to two angles and an included side in the third triangle. So let's move now to the guide practice example number 1. So use angle side angle to prove triangles congruent. Let's see, what do we have? So we have to write a two-column proof. Let's first check the given. We have QS bisects PQR. What do you mean QS bisects PQR? Let's go and check the figure. Whenever we have QS as a bisector, we have to use the definition of the angle bisector. The bisector cuts the angle into two congruent parts. So because QS is the bisector of PQR, it means that PQR will be cut into two angles. The first angle is PQS, that we named it 1 in this example, and RQS, which was we named it 2. So because QS is the bisector of PQR, we can tell that angle 1 is congruent to angle 2, since QS is the bisector of PQR. Also the given, we have PSQ, the one that with a yellow dot. So PSQ is congruent to RSQ. What do we have to prove here? We have to prove that the two triangle PQS is congruent to the triangle RQS. Let's start first writing the first statement. So we have QS bisects PQR and PSQ congruent to RSQ. This is the given. But since QS bisects angle PQR, as you can see in statement number 2, we can tell that angle PQS is congruent to angle RQS and refer to the given. So angle 1 is congruent to angle 2, which is the definition of the angle bisector. So statement number 2 tells us that angle 1 is congruent to angle 2, or angle PQS is congruent to angle RQS, since QS is the bisector using the definition of the angle bisector. So now up to here, let's see, what do we have? We have two angles in the first triangle, which is PQS. So we have two angles in the first triangle that are congruent to two angles in the second triangle. So let's figure out if we can find the included side. So we know that QS is equal to itself. QS is congruent to itself, since the reflexive property of congruence. So now we have two angles in the first triangle that are congruent to two angles in the second triangle. Not only that, we have two angles and the included side, which is QS, is congruent to two angles and the included side, which is also QS in the second triangle. Here we can use the angle side angle postulate to prove that the triangle PQS is congruent to triangle RQS, which is seen in statement number 4. Now let's move to the guided practice that we have to solve. Let's move. So we have to write a flow proof. Let's see what's the given. The given that ZX bisects the angle WZY. So let's check what do we have. And XZ bisects YXW. So ZX bisects WZY. It means that ZX cuts WZY into two equal angles referred in the figure angle 1 and angle 2. So because ZX bisects WZY, it means that the measure of angle 1 is equal to the measure of angle 2. Angle 1 is congruent to angle 2. Also we have XZ bisects YXW. YXW. It means that XZ cuts YXW into two equal angles referred in the figure as angle 3 and angle 4. So since XZ is the bisector of YXW, angle 3 is congruent to angle 4. We have to prove that the triangle WXZ is congruent to the triangle YXZ. So let's start writing the given. We have ZX bisects the angle WZY. Because it's bisect, we can use the definition of the bisector, identifying that the angle WZX, which is referred in the figure as angle 1, is congruent to angle YZX, which is angle 2 in the figure. So since ZX is the bisector, WZX is congruent to YZX, so angle 1 is congruent to angle 2. Also we have ZX is the bisector of the other angle X up top, the big angle WXY. Because it's the bisector, it means it cuts it to two equal angles. WXZ is congruent to YXZ, so angle 3 is congruent to angle 4. So now we have two angles in the first triangle that are congruent to two angles in the second triangle. Also we have ZX is congruent to ZX itself, which is the reflexive property of congruence. So now we have angle, side, angle postulate to use to prove that the two triangles WXZ is congruent to the triangle YXZ, because we have two angles in the first triangle that are congruent to two angles in the second triangle. Not only that, we have the included side between those two angles, which is ZX, which is the included side between the two angles referred by 1 and 3. So ZX is the included side between angle 1 and angle 3. Also ZX is the included side between angle 2 and angle 4. So in those two triangles, we have two angles and an included side that's congruent to two angles and an included side in another triangle, which is the angle side angle postulate that's used to prove that those two triangles are congruent. So angle side angle, let's move. So it's the angle side angle, and remember the side should be included, so the side between the two angles. So in the triangle ABC we have B 40 degrees, C 60 degrees, and BC, which is the included side, 6 centimeter. And in the triangle PQR we have Q as 40 degrees, R as 60 degrees, and QR as 6 centimeter. In those two triangles we have angle B congruent to angle Q, angle C is congruent to angle R, and BC is congruent to QR. So we have two angles and the included side congruent to two angles and the included side in the second triangle. So those two triangles are congruent using the angle side angle, and remember the side should be included within the two consecutive angles we have. So now what about the second postulate, which is the angle side postulate, or the AAS postulate? So we also have two angles similar to the angle side angle. So we have two angles and the side included within those two angles. But now we have angle side. So we have two angles and the side to check in the two triangles, similar to the upper postulate. But what's the new thing about the angle side postulate? So let's see what's the second postulate is all about and how can we use it to prove two triangles congruent. And now let's learn about the second postulate in this lesson, which is the angle side postulate, or the AAS postulate. This postulate is also used to prove two triangles are congruent. But let us see how. What should we have in order to use the angle side postulate? If two angles and a non-included side, so the side shouldn't be between those two consecutive angles. It can be any side in the triangle. So if two angles and the non-included side of one triangle are congruent to the corresponding two angles and the side of the second triangle, then the two triangles are congruent. So in the angle side postulate, we need two angles in the first triangle that are congruent to their corresponding angles in the second triangle, and we need a non-included side, so the side shouldn't be between the two angles like the previous postulate, yet it can be any side that's congruent to its corresponding side in the other triangle. Using the angle side postulate, we can prove that the two triangles are congruent. Let's see, what do we have in this example? We have angle A congruent to angle D, and angle B congruent to angle E. So we have two consecutive angles in the first triangle that are congruent to their corresponding angles in the second triangles. Now the only thing we need is a non-included side, which is any side. So as you can see, BC is congruent to EF, where BC is not included within angle A and angle B. So using the angle side postulate, we can prove that the triangle ABC is congruent to the triangle DEF, since we have two angles and an unincluded side of the triangle ABC that's congruent to the corresponding two angles and the side of the triangle DEF. So let's move. So let's practice a bit. Are the following triangles congruent? How did you know? Let's check the first figure, the triangle ABC and the triangle NCM. We know that the angle B is congruent to angle M, and since AN and BM intersect at point C, it means they form vertical angles. So angle ACB is congruent to angle NCM as shown in the red dot. So we have two angles in the first triangle that are congruent to two angles in the second triangle. So two angles in the first triangle are congruent to their corresponding angles in the second triangles. We know also that AB is congruent to NM, which is the non-included side in the triangles we have. So we have two angles and a side, and the side is not included. So here we can use the angle side postulate to prove that the triangle ABC is congruent to the triangle NCM. Let's look at the second figure we have. We have triangle BSQ and triangle WHP. We have that BS is congruent to WH and SQ is congruent to HP. So we have two sides in the first triangle congruent to their corresponding side in the second triangle. So we don't have enough information to use any of the postulate we have, so we skip. We know nothing about those triangles. So let's move down. Let's check in this figure we have in the triangle KEL and the triangle RES. We know that angle R is congruent to angle K. Also angle RES is congruent to angle KEL, since they are vertical angles and vertical angles are congruent. So in those two triangles, I have two angles in the first triangle that are congruent to their corresponding angles in the second triangle, which is angle R with angle K and angle RES with angle KEL. So we have two angles in the first triangle congruent to their corresponding angles in the second triangle, and we also have the side EL congruent to ES, but this side is non-included side. It's not included within the angles we have. So here we can use the angle side postulate to prove that the triangle KEL is congruent to the triangle RES. While the last figure also here we have two triangles where the only information we have that the two sides in the first triangle are congruent to their corresponding side in the second triangle, and also here we don't have enough information to clarify that those two triangles are congruent. Now, in order to understand those two postulates more and not to mix them up, let's move to the second slide. Let's see what do we have here. Angle, side, angle. In the angle, side, angle, we have two congruent consecutive angles with the side in between those two angles. Just like it's written, the S is between the two A's. So the side is between the two angles we have. Versus in the angle, side, we have two congruent angles, and those angles are also consecutive. But in this case, the side is not included. The side is not in between those two angles, yet the side comes after them. So the side is not included within those two angles. So in both postulates, we have two angles and the side to compare within two triangles, but the location of the side that will help us determine which postulate to use. So in case of the angle, side, angle, the side is included, while the angle, side, the side is not included. So the main difference between the two postulates is that the side in the angle, side, angle, or the ASA is included, and the side is not included in the angle, side. So let's look at the figures we have in below over here. Which one is which? So let's figure out where we are using the angle, side, angle postulate and where we are using the angle, side postulate. So in triangle ABC, we have, and in triangle ZYX, we have angle A congruent to angle X, angle B congruent to angle Y. Not only that, we have the side AB, which is the side included within the angles A, and angle B is congruent to the side XY, which is the side included within angle X and angle Y. So we have two angles and the included side. So look, angle A is congruent to angle X, B congruent to angle Y, and the included side AB is congruent to the included side XY. So we have two angles and an included side congruent to their corresponding angles and the included side in the second triangle. So here we can prove that the two triangles ABC and XYZ are congruent using the angle, side, angle postulate. Let's look at the other two triangles. Let's look at triangle KML and UST. So angle K congruent to angle U, good. Angle M is congruent to angle S. We have two angles in the first triangle that are congruent to their corresponding angles in the second triangle. So what about the side? Is KL the side included within the two angles K and M? No, KL is the side that's not included within the two angles. So here, is it the angle, side, angle postulate we're gonna use, or the angle, side postulate? We're gonna use the angle, side postulate, since KL is congruent to ST and those two sides are not the included side within the angles we have. So triangle KML is congruent to UST using angle, side postulate, since the side is not included within the two angles we have. So let's move now to example number 2, which is the guided practice. So here we're going to use the angle, side to prove triangles congruent. So this postulate is used to prove two triangles are congruent. So we have the given as angle DAS is congruent to angle BEC. So technically angle A in top is congruent to angle E down. So we have angle A congruent to angle E. Not only that's the given, we have DC congruent to BC. So we have a side congruent to another side. So we have to prove that the triangle, look, ACD is congruent to the triangle ECB. So up to now we have that angle A up top is congruent to angle E. Also, both triangles share the same vertex C, so angle C is congruent to angle C itself, which is the reflexive property of congruence. So up to now we have two angles in the first triangle that are congruent to two angles in the second triangle, and from the given we know that DC is congruent to BC, so we have two angles in the first triangle that are congruent to their corresponding angles in the second triangle, and we have a side in the first triangle congruent to its corresponding side in the second triangle. And pay attention, the side here is not included. The side is not included, so here we're going to use the angle side to prove that the triangle ACD is congruent to the triangle ECB. Now let's move to the guide practice number 2 that we will solve in the next slide. So in exercise number 2, the given now is that RQ is congruent to ST and RQ is parallel to ST. What we have to prove is that the two triangle RUQ is congruent to the triangle TUS. We're gonna start with writing down the given. So RQ is parallel to ST. It means we have a pair of alternate interior angles formed, which is the RQS. So the RQS and the TSQ. So angle Q and angle S are alternate interior angles, and alternate interior angles are congruent. So angle Q is congruent to angle S. Not only that, RT and SQ are intersecting at point Q. So we have vertical angles. So angle RUQ is congruent to angle SUT. Vertical angles are congruent. So let's see what do we have up to now. We have that angle Q is congruent to angle S. So angle Q in the first triangle is congruent to angle S in the second triangle. And angle RUQ in the first triangle is congruent to SUT in the second triangle. So we have two angles in the first triangle that are congruent to their corresponding angles in the second triangle. So now let's search for the side. RQ is congruent to ST, and that's given, and pay attention, RQ is not the included side within those two angles. So now we can prove that the triangle RUQ is congruent to the triangle TUS using the angle side, since we have two angles and the side in the first triangle that are congruent to their corresponding angles and the side in the second triangle. So let's move now. So here, let's do a wrap up for what we learned up to here. To prove two triangles congruent, we can use 4 postulate. SSS, which is the side postulate, that tells that all 3 corresponding sides must be congruent. The side, angle side. 2 sides and the angle between them must be congruent. Angle side angle, which is what we learned in this lesson. So we have 2 angles and the side between the side included within those 2 angles must be congruent. And the angle side, the 2 angles and non-included side must be congruent. And here's the summary for proving triangles congruent. SSS, 3 pairs of corresponding sides are congruent. SAS, 2 pairs of corresponding sides and their included angles are congruent. ASA, 2 pairs of corresponding angles and their included sides are congruent. And the last postulate, which is the angle side postulate, or the AAS, 2 pairs of corresponding angles and the corresponding non-included sides are congruent. All those 4 postulates are used to prove triangles congruent. So let's have this exercise number 30, book page number 318. They're saying which additional information could be used to prove that the triangle QRU congruent to the triangle TRS. From the figure, let's check what do we have. We have that UR is congruent to SR. And also we have QRU is congruent to SRT, since they are vertical angles. So let's check part A. If they told us as well that QR is congruent to TR, isn't it here we have the side UR is congruent to SR? And from part A, we have QR congruent to TR, and angle QRU is congruent to SRT, since they're vertical angles. So here we're using side postulate. And yes, part A can be used as an additional information to prove those 2 triangles are congruent using the side postulate. If they told us QU and TS are congruent, so we have 2 sides in this triangle that are congruent to two sides in the second triangle, and we have an angle here and an angle over here. So we have the QRU and the SRT. So we don't have a postulate that tells us if we have two sides and any angle in the first triangle that are congruent to two sides and any angle in the other triangle that we can use it to prove two triangles are congruent. So B cannot be used as an additional information. If they told us US equal double RS, also it cannot be used. If they told us angle U is congruent to angle S, so angle U congruent to angle S, UR is congruent to angle SR, and angle QRU is congruent to angle SRT. So we have an angle, side, then an angle where UR is included within angle U and angle R, and SR is the side included within angle R and angle S. So part D can be used as an additional information to prove that the triangle QRU is congruent to the triangle TRS using the angle, side, angle postulate. Angle E, if they told us QRU is congruent to the triangle TRS, this is not an additional information. We know that from the figure, since QT and US intersect at R, so they form directly vertical angles, and vertical angles are congruent. And if they told us R is the midpoint of US, and also this is shown in the figure, this is not an additional information. And now let us check exercise number 31, book page number 318. We're given that the triangle ACD and the triangle CAB congruent. So the two triangles are congruent. Also AD is parallel to BC. What is the measure of the angle CBA? So we want the measure of angle B. So to find the measure of angle B, we need first to find the measure of angle D. Since angle B is congruent to angle D in the second triangle, since those two triangles are congruent, they form the CPCTC. Congruent parts of corresponding triangles are congruent, and those are angles. Their corresponding angles are congruent. So the measure for angle B is the same as the measure for angle D. So to find the measure of angle B, it's as if we want to find 3x. So we need to find x first. So to find x, let's look at the triangle first, ACD. The measure for angle DAC is 2x plus 8 degrees. And the measure for angle D is 3x degrees. So what about the measure for angle ACD? The angle ACD is congruent to the angle CAB, and they're both equal to 37 degrees. So now on the triangle ACD, we know that the sum of the interior angle equal to 180 degrees. So if we try to add the measure of the three angles in the triangle ACD, they must be equal to 180 degrees. So now we write down an equation in order to find x. So the equation is 3x plus 2x plus 8, which is the measure of the second angle, plus 37. Let us solve. We get x equals to 27. We substitute instead of x 27. So the measure for angle CBA is equal to the measure of angle ADC, which is 3x, which is 3 times x, which is 81 degrees. This is our lesson. Thank you for listening.